Section 1.4, multiplying and dividing integers. It's going to be a fairly short video, but I don't want to give the impression that it's not important. The bottom line here, and if this is the only thing you take away from the video, let it be this, it'll be good, is that we're trying to memorize these three cases over here on the left. Okay? Case 1, case 2, case 3. Three configurations where we're going to be given groupings of positive and negative numbers, and the result is going to be influenced by how those numbers are configured. This is something that you're going to run into with nearly every equation that you work and expression that you work. So it's very critical that you memorize these cases. That really is all there is to it, to this section. At the end, we are going to do a little bit of expression simplification, kind of leading into our order of operations. But what's critical here is realizing that you need to memorize these case laws. That's the bottom line. So I'm just going to pick a couple of products, a couple of quotients, and a couple of simplification problems from page 17, the exercises for 1.4, and I'm going to do them for you and kind of give you an idea what's going through my head. So just a couple quick problems here. So, okay, let's do number 3, 6 times 2. 6 times 2. Pretty standard. We got a positive number on the left. We got a positive number on the right. We're going to look over at our case law. Well, that seems to match case 1. A positive times a positive, realizing, of course, that between these, when we see two sets of parentheses together like this, that means multiplication. And the result is going to be positive. So whatever this ends up being, and of course it's 12, this result is going to be plus 12, but we would not leave the plus sign in there. We would just write 12. So the answer is 12. Pretty straightforward. Next, let's do, let's see, how about negative 4 times 5? Negative 4 times positive 5. So you got a negative over here, you got a positive right here. Let's go look at our case law. Well, looks like that matches case 2, a negative multiplied by a positive, or a positive multiplied by a negative. These could be switched around just as easily. And our result is going to be negative. It's going to be equal to negative, and 5 times 4 is 20, negative 20. It's just that simple. Mistakes happen if you get in a rush, but as long as you memorize your case laws, there's no way you could ever go wrong. Okay. Let's look at number 5, just because it's kind of a curious case. Let's see. So negative 1 times 0 equals what? We got a negative times 0. Anything times 0 is going to be 0, but you can still sort of use your case laws to get you in the right direction. That is to say, you know that it's not going to be a positive number. You know that it's going to be a negative number. If this were 1 or something right here, then you would know that it'd be negative. Negative times a positive. But in this case, just realize it doesn't matter what your rules are. If you're multiplying by 0, your result is just going to be 0. Okay, so let's do a couple of quotients. The rules don't change for quotients, division problems, that is to say, but what does happen is some of the signage can get a little bit more complicated and difficult to understand. So let's just kind of play with a couple of these here. Let's see. Which one do I want to do? Let's do negative 27 divided by, what is it, 3. Oops. Negative 27 divided by 3. So first of all, let's figure out our sign. We know that our answer is going to be negative, because if we look over here at case 1, or rather case 2, we've got a negative 27 divided by a positive 3, so that we know our solution is going to be negative. We're following case 2 here. So however we arrange this division problem, we know that the result is going to be a negative number. And I could write it like this, negative 27 divided by 3, or I could write negative 27 times 1/3 is another option. There's a lot of different configurations we can write with division, so it can get a little bit tricky, but just realize that however it's written, the idea is still going to be the same of referring to the case laws. And so it just so happens that 27 divided by 3 is 9. And you can work that out however you see fit, but the case law applies. Our answer is going to be negative 9, or rather, negative 9. Next, let's do 15 divided by negative 1 is an easy one. Nice conceptual problem. 15 divided by negative 1 is equal to something. In this case, let's do 15 divided by negative 1 this way, just to kind of give you a glimpse into how I might work this problem in my head. Later in algebra, you'll learn that you can, using these properties that we're learning today, what it basically becomes is that this negative can come out. It can be at either the negative 15 or the negative 1. It's irrelevant. But when you look at something as a ratio like this, it can kind of make it a little bit easier. But again, positive number on top, negative number on the bottom, or in the case of the top line, positive number on the left, negative number on the right. Irrelevant. The bottom line is we've got case 2, and the result is going to be negative. 15 divided by negative 1 is negative something. 15 over 1 is 15. Okay? There's a couple of quotients for you. So again, bottom line is memorize those case laws and work as many problems as you possibly can, and eventually you'll get so good at this that it'll be like breathing. And if it's starting to frustrate you, just realize that that's when the learning is starting to occur. As far as simplification goes, I will do a couple of problems out of the last section here on page 17, but I think it'd be more appropriate right now for me to take this gigantic expression over here on page 16 and kind of work through it the way I would do it. So I'm going to write it down, and then I'm going to work it for you. So what do we got? We've got in parentheses 8 minus 7 plus x times 1 plus 3 plus 4 plus 3 plus 4 plus y times minus 5 minus 2 plus 1. Run that space plus z times 3 plus 1. Okay, ran out of space a little bit there, but you can see it. Not to give too much of a glimpse behind the curtain, but I'm sure you can see over here I've got this parentheses, exponents, multiplication, division, addition, subtraction line over here. And, that's your order of operations, and that's going to be what I'm thinking about when I work a big expression like this or an equation. Because that's what algebra is you take this big template, you make it really ugly, and then you sort of use the operations that we're learning over the last couple of videos and sections in our textbook to reduce this complicated, jumbled mess into something that's a lot more comprehensible. And we do that in a certain order, and it just so happens that we go from top to bottom in this order of operations, starting with parentheses, and that's what I'm going to do here. So everywhere I see a parentheses, I'm going to start reducing. Okay, so 8 minus 7 is 1, so I'm going to reduce that, plus x, and in this parentheses, I'm going to reduce 1 plus 3 plus 4 into 8, I believe, yeah. Plus y, and I'm going to reduce this next set of parentheses to, okay, so negative 5 minus 2 plus 1 is, let's see, minus 6. Minus 6 plus z, what's 3 plus 1 in this last set of parentheses? That's 4. That gives you that, okay? Now, once we get to this point where the parentheses are fully reduced, now we can just apply the number that we came up with as a result as a coefficient to the variable that they were associated with. That is to say that we can take this 8 and drop the parentheses and just put it right next to the x, and we'll know that we're multiplying x 8 times. So all I'm going to do is reduce my expression a little bit further just by writing it out like that. It's going to be 1 plus 8x plus minus 6y plus 4z. Well, we learned in a previous video that plus and minus together, well, that's just minus, so we'll drop our addition sign. 1 plus 8x minus 6y plus 4z. And that's the answer. So you can see how the idea here is to take something that is relatively complicated, like this line up here at the top, and reduce it as much as we can in tiered steps till we get to a point where it's as fully reduced as we can make it, as simple and easy to understand as we can make it. And that's what simplifying expressions is. So you can see how there's a lot of opportunities for me to have issues with my signage. For example, here, negative 6y. I had to know my case laws for that one right here. Here's an addition case law right there, where I had to know that a negative and a positive together ends up with a negative. So you can see how just working these problems over and over again, and as many examples as you can possibly give yourself, is going to give you the sort of muscle memory that it takes to work efficiently with these case laws. From chapter 7, or from page 17, just a couple of examples real quick. If we've got 3x plus 4x, what we're doing is we're combining like terms here. So anytime you see same order terms, that means that they're like terms. So for example, if this was 4x squared instead of 4x, those wouldn't be like terms. Those would be completely different. Or rather, if it was instead of 4x, it was 4y, well, those aren't like terms anymore. Or if it was just 4, again, these are not like terms. So things that are multiplied or divided by each other with the same magnitude, or what we call like terms. So in the case of 3x plus 4x, we just need to recognize that, hey, we're adding like terms, and this is going to give us 7x. I have 3x's, I add 4x's to them, I end up with 7x's. I mean, we can backtrack it as far as you like. If they were apples and oranges, you can't add oranges to apples and equate that to some common fruit. That's not, that's not how it works. They have to be similar. It has to be apples and apples, oranges and oranges. Another one, minus 7x minus x, minus x. Here we just pretend that there's a little 1 right next to this x, okay, so minus 1x. So we've already, so again, we're going back to our addition and subtraction rules here with the number line. 7 movements to the left plus another movement to the left, so a total of 8 movements to the left, that's minus 8. Okay, and then with the x tacked to it, because they're like terms. Again, there's a little 1 right next to that x, so we don't write. Okay, one more, a little bit more complicated, and then we'll wrap it up. Let's see here. How about 3 minus 12 plus x minus 6x? Minus 12 plus x minus 6x. Okay. Like terms. We have to think of this as addition and subtraction of like terms. So where do we see like terms? Well, we've got an x here, and we've got a minus 6x there. Those terms are alike. And then we've got a 3 here and a 12 here. Those are like terms. So we're going to separately combine those into a single expression. So first of all, 3 minus 12. Well, the difference between 3 and 12 is 9, and we've got a negative number here, so it's going to be minus 9. And then plus, combine like terms on this other side here with these x's. X minus 6x, well, that's minus 5x. And now we're back down to our addition and subtraction issue here, and we need to recognize that a plus and a negative is a negative, so you've got minus 9 minus 5x is your answer. Oops. Got a little messy there, but you see the point, which is that these rules that we're learning have to be applied dynamically while we're exercising these problems and reducing these expressions. This is the solution to number 19. So again, that's it. And just to kind of polish it off here, in summary, the point of this section is to memorize these 3 case laws. And if that's the only thing you take from this video, let that be it, because that is absolutely valuable. Thank you.